Hello, today we will be looking at section 7.4, trigonometric form of complex numbers. This is Mrs. Thompson, of course. Looking at the complex plane, with the complex plane, the horizontal axis is referred to as our real axis, and your vertical axis is referred to as your imaginary axis. Another way of thinking about this is what is commonly referred to as the x-axis becomes the real axis in the complex plane, and what is commonly referred to as the y-axis becomes your imaginary axis in the complex plane. Looking at an example of graphing a complex number. So with the complex plane, your first coordinate is referred to as A, and it is the real part. Your second coordinate is referred to as B, and it is the imaginary part. So of course, instead of X and Y, which you are familiar with the rectangular coordinate system, it is A and B for our complex numbers. Looking at graphing the complex number -3 minus I. So our real portion, -3, we find that on our real axis. We go over to -3. The imaginary part, -I, which we know is understood to be -1I, meaning we go over or we find -1 on our imaginary axis. And just like with our x and y axis, our point belongs where -3 on our real axis and -1 on our imaginary axis intersects. An important reminder and connection. Earlier we learned that x equals r cosine theta and y equals r sine theta. In the complex plane, the first coordinate is referred to as A, and the second coordinate is referred to as B. Therefore, A equals r cosine theta, and B equals r sine theta. So in the complex, when dealing with in the complex plane, we do not have x and y. X is replaced with A, and y is replaced with B. An introduction to converting complex numbers to trigonometric form. We will conclude this so that you have a good understanding of this with an example. But this conversion is done to make multiplying, dividing, along with finding powers and roots easier. So a complex number in standard form or standard form of a complex number is a plus bi. And in trigonometric form, this same number would be r times the quantity cosine theta plus I sine theta. And for your angle theta, you always use the smallest value, the smallest angle measurement that is non-negative. The formula for r is the square root of a squared plus b squared. Now, an example of converting complex numbers or an example of converting a complex number to trigonometric form. We are given the complex number -2 times the square root of 3 plus 4i. To convert to trigonometric form, r and theta must be found. This is a fact you have to learn. So, finding r, we have a formula for r. So we simply plug in the value for a, -2 times the square root of 3 into the formula, and the value for b, which is 4, into the formula, and do what the formula says using the order of operation. Square, add, and then take the square root, giving us a square root of 28. And when we simplify that, the square root of 28 is 7 times 4. 4 is a perfect square, so we pull that from under the radical. The square root of 4 is 2. 7 is a prime number, so it remains under the radical. Now finding theta. We use the equation, you may call it a formula, which is fine. A equals R cosine theta to find theta. It's an equation where we know everything except for the value of our angle, the value of theta. So as long as we have only one unknown, we can solve for it. We know that A equals -2 times the square root of 3. We just finished finding R, 2 times the square root of 7. We plug those right in. Here it is. Substitute it in. And then we solve for the cosine of theta because we do not separate when the trig function from the angle. 2 times the square root of 7 is being multiplied by the cosine of theta. So to move it to the opposite side of the equation so that the cosine of theta is all by itself, we would divide. So the cosine of theta is equal to -2 times the square root of 3 divided by 2 times the square root of 7. And then, of course, to find the angle measurement, the value of theta, we must take the inverse function. So with your calculator, take the inverse cosine of -2 times the square root of 3 over 2 times the square root of 7. We're in degrees, so make sure your calculator is in degrees, for a final answer for theta of 130 9/10 degrees. So now that we have the value for R, and the value for theta, we just plug that into our trigonometric form. So in place of theta, we write 130 9/10 in both locations where theta would be located in trigonometric form, and where R belongs in trigonometric form, we plug in its value, 2 times the square root of 7, and now the complex number that was given to us is in trigonometric form. Now converting in the opposite direction. How to convert a number in trigonometric form to a standard complex number. Well, to do so, you evaluate the trig function and distribute. So let's look at our example. Evaluating the trig function. If it's a common angle, you should remember the value. If it's not a common angle, you can plug it into your calculator. So the cosine of 130 degrees, here is its value. Likewise, the sine of 130 degrees, you could use a calculator for this one also. We have the answer. It will give you your answer. Bringing down the plus I and your value for R, 3.5. So we have evaluated the trig functions. Now distributing. So taking the 3.5 on the outside of the parenthesis, multiplying it by both numbers inside the parenthesis, we get a final answer when round or holding on to 3 places behind the decimal and round to the thousandths place of -2 and 250 thousandths plus I times 2 and 681 thousandths. Here are the formulas for multiplying and dividing complex numbers in trigonometric form. The formulas tell you exactly what to do. We will look at this in detail with an example of each. Multiplication example. Our formula tells us to multiply our two R values, so the two numbers in front of the parentheses. 8 times 3, which is 24. Our formula tells us to add the measures of our angles. So 100 plus 35 gives us 135 in both parentheses. Of course, for this, going ahead and copying, I will say the rest of the trigonometric form, placing cosine in front of 135 degrees first and plus I sign in front of the 135 degrees secondly. Now, evaluating the cosine of 135 degrees, common angle, negative square root of 2 over 2, and the sine of 135 degrees, square root 2 over 2. Now distributing, multiplying both values by 24, and simplifying, multiplying 24 times negative square root of 2 over 2 gives us just that, and 24 divided by 2 is 12. And the problem is complete after the distributing. Final answer of negative 12 square root 2 plus 12I square root 2. Division example. Our formula tells us to divide our R values from top to bottom. So 9 divided by 3 is 3. In our parentheses, in our final answer, we are told to subtract the measures of our angles, our theta values, from top to bottom. So pi by 4, subtract 5 pi by 4. In both parentheses, we have to actually perform that subtraction. Pi by 4 is the same thing as 1/4 pi. Excuse me, yes, same thing as 1/4 pi. So 1 minus 5 is negative 4. Holding on to our common denominator of 4. Negative 4 over 4 gives us negative 1 pi, which of course we write as just negative pi with the 1 understood. Same subtraction problem again in the other parentheses, so the same answer. Evaluating our trig functions, common angle of pi. The cosine of negative pi is negative 1. Again, that common angle of negative pi. The sine of negative pi is 0. Distributing, 3 times negative 1 is negative 3. 3 times 0 is 0. Adding 0 to negative 3 does not change the value. So a final answer of negative 3. Our final concept in this lesson, the conjugate. So in standard form, the conjugate of a plus bi is a minus bi. And in trigonometric form, the conjugate of r cosine theta plus r sine theta is r cosine negative theta plus I sine negative theta. And here you have an example that you may use. Another multiplication example of taking the product of a number in trigonometric form and its conjugate, which will be, of course, another number in trigonometric form.